good morning, and sorry I can't be there today. I have a sick child and I need to get to the doctor. So the notes are going to be on here. I just need you to watch these and take notes on the paper that the sub has given you. So we're going to be working on finding inverses, and basically the inverse is like the undoing equation, and we're going to get there in a minute. But understand that when we have a set of ordered pairs, every ordered pair is a combination of an input and an output. For instance, the ordered pair 2 comma 3 means that I plugged 2 in and the answer to the problem was 3. And we know that we can plot those. So as each little checkpoint says, first thing I want you to do is plot each point. So go over 2, up 3, put a dot, go left 5, down 2, and I don't know what this weird little smart notebook thing is on here. Go left 1 and up 4 and put a point there, left 9 and up 1, and finally right 1, up 6 for your last point. So that takes care of plotting all those points. And then it says I've already drawn the line y equals x on the graph. So I just want you to go over here and I want you to label it. So this diagonal line is the line y equals x, meaning that if I go to any point on there, like this point, for instance, that I just marked, is that x is 5, y is 5. So both of the values are the same, is all that means, okay? The next, it says to interchange all your x and y values. Interchange means switch them with one another. So if I switch them, then the first one I have here would be 3 comma 2. The x number becomes the y number and vice versa. So -5, -2 is next. 4, -1. And you can see I'm not changing anything other than their order. Like the values of them are staying positive and negative as they were. And now what I want you to do is plot those values. So plot your new points. Whoops, don't know what happened there. Right 3, up 2. So there's that first one. Left 2, down 5. Right 4, down 1. Right 1, down 9. And last, right 6, up 1. And then it says compare. So this that I just did in blue represents g of x. So now I want you to compare. And if you look, what you notice is that f of x and g of x are a reflection of each other. Across that line y equals x. So if I folded my paper along this diagonal line y equals x right here, then what I would see is all those values would match up if that was where I folded the paper. So do the same thing on here, and this time I want you to use this special notation, which is our inverse notation. So rather than say f of x and g of x, we just base it off of the original. So since the original was h of x, we say h inverse. When we see the little -1 exponent, we read that as inverse. So h inverse of x is, and then we would exchange these, -1, 3, 2, -7, 5, -4, 6, 0. And then that's all you do for the inverse. And yes, that is all you do. So the final stage is actually being able to find the equation for the inverse. And the equation is important because this is what I always refer to as like the undoing equation. And I call it that because if I take an equation and I multiply it by 6 and then subtract 5 from it, then to get back to what I started with, I have to reverse each one of those things. So if I'm multiplying by 6, then eventually at some point I'm going to have to divide by 6. If I'm subtracting 5, at some point I'm going to have to add 5, because those are the things that undo adding and subtracting. So the first step, and it's listed pretty clearly, is to replace y instead of f of x. So this first one down here, instead of this fancy f of x notation, the only thing I'm going to do is exchange that and make it y instead. So everything else currently stays the same. So I still have my negative 1/3 x plus 1. That takes care of step 1. Step 2 says to switch your x and your y. Just like we did before, when we exchange them, x and y are partners with each other when it comes to inverses. So that means that I'm going to leave the negative 1/3 and the plus 1 where they are, but this is now going to become my x, and this is going to become my y. They change spots. And then our final thing, and this part right here could take a couple steps, is to solve for the y variable. So you want to get this y variable by itself. So right here, our job is to get that alone. So you have to analyze what is happening to that y value in the first place that I need to undo. Well, you undo things in opposite order. So sometimes it helps people to think about, like, well, what happens first? So they make like a little cheat sheet. So over here to the side, if I plug something in, I would first multiply by that negative 1/3, and then I would add 1. This is the original. Okay, so this is in the original one. If I'm reversing that, then I'm going to take that last step and I'm going to think, how do I undo adding 1? Well, I would have to subtract 1. And how do I undo multiplying by negative 1/3? Well, a lot of you are going to tell me division, but because it's a fraction, I'm going to say, how about multiply by negative 3 instead? That is the same as dividing by negative 1/3. So you have to choose which one. Okay, this one right here is just a little bit cleaner. So the first thing I'm going to do is subtract my 1 from both sides. And what happens is I can't really do x minus 1, so I have to leave it as x minus 1 in that form. And then I have to undo that dividing, or that multiplying by negative 1/3. So I'm going to wrap some parentheses around this, and likewise on this side. Here I'm going to multiply by negative 3, which is going to offset that, but I have to do the same thing on the other side, which is where I'm really going to actually see the problem. So I have negative 3 parentheses x minus 1 equals y. And then we can simplify that just a little bit more, which is going to give us negative 3x plus 3 when you distribute. And now we're going to go back to our old notation, which was f of x notation, but we're going to write it as f inverse because this is the undoing equation. So since it's the inverse, this would be our final answer. So let's go back to the second one. And you can stop this video at any point and kind of analyze and kind of replay what just happened so that if you need to see it a second time, you can. So if I look at this one, okay, first thing I'm going to do is make myself a little cheat sheet of what's happening. If I were to plug in something here for x, the first thing I would do is multiply by 2, and then I would subtract 1. So to undo that for the inverse, I have to take this guy at the end, and it becomes my first move. So how do I undo subtracting 1? I'm going to add 1 first. And then how do I undo multiplying by 2? I'm going to divide by 2. So that tells me exactly which steps I'm going to need for this problem. So first thing I do is change this to y equals. No more fancy notation for a few minutes. Switch my x with my y. Then I can do these steps that we talked about up here, which first step we said was to add 1 piece of cake. So I get x plus 1 equals 2y. And then we said we would have to divide by 2. Now, dividing by 2 over there should be a piece of cake. It just goes away. Make sure you put that divide by 2 under everything on this side. So instead of this y now, replace it back to inverse notation, and then write everything that you had on the other side. So when you tear down one side, you should be building up the other. Okay, let's try this one a little bit faster. Here's our equals line. So y equals 2x minus 5 all divided by 7, which, okay, now before I start doing anything, I'm going to make my little cheat list. So I have my f and my undoing. So the first thing, think about if you were plugging into the original equation right here, what would you do? First, you'd multiply by 2, then you would subtract 5, then you would divide by 7. Your undoing list reverses the order. So first, undoing divide by 7 would mean multiply by 7. Undoing minus 5 would be plus 5. Undoing times by 2 would be divide by 2. And all your things now just have to be put in play into this part of the problem where you solve it. So first thing it says is we have to multiply by 7. So I'm going to take that 7 times my x, and then it goes away on this side. Then I'm going to take my 7x, I'm going to add 5. That gives me 7x plus 5 equals 2y. Then we're going to divide the whole thing by 2. So that goes away. And then you are going to trade that back for your regular notation of f of x. And you get 7x plus 5 divided by 2. Okay. Hit pause and try to do this one. Make sure you first start with the list of what is happening, if that's helpful to you. So I'm going to make that list first. I would first square root and then subtract 10. So my undoing list is going to include add 10 and square it. Okay, so switch this to y equals, switch my x and my y, add that 10 on both sides. So I get x plus 10 equals square root of y. And then undo a square root by squaring it. And when you square, because you have x plus 10 already together, you have to put parentheses around that. So you currently have parentheses around x plus 10, it's being squared, and now you just have y. So switch it back to fancy notation. F inverse, this one's called F, right? Yes, they all were. F inverse of x equals x plus 10 all squared. Okay, that's it. Hit stop. Go get your assignment from the sub and get after it. Turn that assignment in today.